Alright, so the Pythagorean theorem is used for finding a missing side on right triangles. So the Pythagorean theorem only applies to right triangles. And the Pythagorean theorem is named the Pythagorean theorem because it is named after a Greek philosopher and mathematician, Pythagoras. But we really don't know if he's the actual one who discovered the theorem. Lots of people were kind of making these same discoveries, but he's the one who got credit for it. So Pythagoras lived in Greece at a time where the church did not really want people studying math and science. So he was one of the leaders of like a secret society. They were called the Pythagoreans. And I always think that's one of the coolest things about the history of math is that a lot of mathematical ideas got started in these secret societies. So you may remember that the Pythagorean theorem goes like this: a squared plus b squared is equal to c squared. And what those variables stand for is that when you have a right triangle, the side that is across from the right angle is named the hypotenuse. And the hypotenuse is always where the variable c goes. The variable c always goes across from the right angle on the hypotenuse. And it is also a true fact that the hypotenuse is always the longest side. Now, let's think about that. A triangle adds up to 180 degrees, right? If this angle is 90, these other two have to each be less than 90. Because if they were more than 90, it wouldn't be a triangle. It would be higher than 180. So this 90 degrees is the biggest angle, so the side across from the 90 has to be the biggest side. So that's always a true fact. Now, the other two sides are each named a leg. So this side is a leg, and this side is also named a leg. And the two legs are A and B, but it doesn't matter which one is which. So you could call this one A and this one B, or you could call this one B and this one A, and that part doesn't matter because they're both called legs. Notice that the legs are the sides that form the right angle. So this leg touches the 90 degrees, and this leg touches the 90 degrees. The hypotenuse does not touch the 90-degree angle. Alright, that's the hardest part right there. Just knowing what everything is and where it goes. Alright, so now let's do some examples. Suppose I have a right triangle, and this leg is 3 meters, and this leg is 4 meters, and we want to find C, the hypotenuse. So we write down a squared plus b squared equals c squared. The Pythagorean theorem. And then we substitute in the numbers that we know. So these two sides are A and B. It doesn't matter. I'm going to say this is A and this is B. But if you said it the other way around, that would be okay. So that's 4 squared added with 3 squared is equal to C squared. So, squaring means to multiply a number times itself. So 4 squared means 4 times 4, which is 16. And 3 squared means 3 times 3, which is 9. Then we add the 16 and the 9 together. And we get to right there, 25 is equal to c squared. And this is the spot that a lot of people get stuck on right here. So we don't want to know what c squared is. We want to know just c, just by itself. So we have to undo squaring. So the way that we undo squaring is with a square root. And remember, on equations, whatever you do on one side, you have to do on the other side. So we're going to take the square root of c squared, and we're going to take the square root of 25. So when you have a number and you square it and take the square root of it, those two operations undo each other. And so c is left by itself. And the square root of 25 means what number can you times by itself that would equal 25? And so that answer is 5. And so we would say the hypotenuse is 5 meters. Now, is it true that the hypotenuse came out to be the longest side? Yes, because 5 is more than 3 and 4. Alright, so you can probably see already that if we're going to be doing the Pythagorean theorem, we're going to be doing squaring and square rooting a lot. So let's take a moment and make a list of some squares and square roots that are just going to be helpful to us. Alright. So if I take the number 2 and square it, 2 squared means 2 times 2, which is 4. So that means that the square root of 4 is equal to 2. So if I take the number 3 and square it, that means 3 times 3, which is 9. So the square root of 9 is 3. 4 squared means 4 times 4, which is 16. So the square root of 16 is 4. So do you see how squaring and square rooting undo each other? If I start on a 4 and I square it, I get 16. And then if I'm on 16 and I take the square root, I get back to the 4 that I started with. Alright, 5 squared, 5 times 5 is 25. So the square root of 25 is 5. And then we'll go one more, 6 squared. 6 times 6 is 36. So the square root of 36 is 6. So this list of numbers right here are called perfect squares. And it's just very good to know that little list. If some of you have never really learned all of your times tables, I would say if you're going to learn any times tables, learn these right here, your perfect squares. They come up a lot in math. Alright, so not every time when you take the square root does it come out exactly as a whole number. So we're going to do another example where we're going to have to do some rounding. So here's a problem. We've got a right triangle. We have a measurement of 2 feet and a measurement of 6 feet. And we're trying to find C, and our instructions say round to the nearest tenth. So we're going to begin with the Pythagorean theorem. 2 squared added with 6 squared is equal to C squared. Because here's my right angle. This is my C. It's the hypotenuse. So it's the longest side. It goes for letter C in the formula. So 2 squared, 2 times 2 is 4. And 6 squared, 6 times 6 is 36. And that's C squared. And then I add 4 and 36 together and I get 40. And then this is where I'm going to take the square root of both sides, because square rooting and squaring undo each other, and this leaves the C by itself. But the square root of 40, nothing times its own self will equal to 40. So we're going to use our calculator. So if you look on your calculator over to the far left, a little bit up from the 7, we've got this button that says x squared. So if you want to square a number, you're going to press this button. So like if I didn't know what 6 squared is, I would do 6 squared. Right? 6 squared is 36. But on top of that little x squared is the square root sign. So you're going to press second square root. That gives you your square root sign. So we want to know the square root of 40. So the square root of 40, and we press enter. And now I get this big long decimal. I'm going to write down exactly what my calculator says. 6.324555532. But this is not really going to be the answer that I record, because it says round to the nearest tenth. So in place value, your tenth place is right there. The one spot right after the decimal is the tenth place. So we have to decide, is this answer right here closer to 6.3? Or is it closer to 6.4? That's really what we're deciding. So if it's more than halfway, we're going to go up to 6.4. If it's less than halfway, we're going to stay at 6.3. Well, how do we know? We look to the right. And that digit on the right, look to the right. And there's a little rhyme. It says, 5 or more, raise the score. 4 or less, let it rest. Means stay where you are. So since I have 6.3 and that's a 2, and 2 is less than 4, my rounded answer is going to be 6.3 feet. That's going to be my answer for C. Now, this is just a, what if I had pressed my calculator and I had gotten an answer like 6.374825? Okay? So now here's my tens place. In this case I would look to the right. 5 or more raise the score. This number rounds to 6.4. This is closer to 6.4 than it is to 6.3. So this is very important because some of your IXLs are going to tell you to round, and you might do the whole problem right, but if you type 6.4 instead of 6.3, IXL is going to do the whole thing wrong and mark down your smart score. You don't want that to happen, so pay attention when you're rounding.